Welcome to your first video tutorial on solving systems of linear equations. Today we're looking at graphing linear equations and solving the system from there. So first of all, looking at your smartboard, you've got two equations on top. So the first thing we're going to do is we're going to look at how do you graph equations just as a general review. So the first thing we're going to do, remember we've got our y-intercept. So right here is our y-intercept, and our slope is in front of that x. So our slope for this equation is -1. So to graph our first one, we have plus 5. That means we start at 5 on the y-intercept. So let's put a dot right at 5 on the y-intercept. And then if their slope is -1, we're going to go down 1 to the right 1. So down 1, right 1, put my next point here. Down 1, right 1, down 1, right 1. And I'm going to create my line from there. So let's put a line in here. So there's my line. And my arrows aren't on either side, so sorry about that. So I'm going to put that arrow over there, so we've got lines on both sides. Next equation, my y-intercept is -7, so I'm going to start down 7 on the y-axis. So 1, 2, 3, 4, 5, 6, 7. So there's down 7 on the y-axis. And I have a slope of 3. That means I'm going up 3 to the right 1. So there's my next line. And then up 3 to the right 1 again. Next line. Up 3 to the right 1, and there's my next one. So I'm going to fill this in to make my line. All right, now you can see these two graphs do intersect. That intersection point is really important because the intersection point is going to be our solution for systems of linear equations. So the big question here is, what is a system of linear equations? So a system is just a set of two or more equations. Like I say, it says 2 or more. So you could have multiple equations. You could have 3, you could have 4, you could have 5, you could have 10. And once you get to that point, there's different ways of solving it. But we're going to go through just a couple of ways to solve it here in Chapter 7 with systems of linear equations. And the solution of a system of linear equation is a point that makes all equations true. And that's going to be the big focus of our first homework. It makes all equations true. So on that first homework, all we're really going to be doing is checking on to see if the point we have makes it true. So consistent independent system, that's just a system, so a set of equations with one solution. So since it has one solution, and we look up at our graph, this one does have one solution. And our one solution is that point where those cross. That's going to be right here. So that solution is at 3, 2. So because we know it has a solution that is a consistent independent solution and system, so we've got a system of linear equations with one solution. So what happens if we have a system? So our system is here is 2x plus 5y equals 9, and y equals 2x plus 4. And you want to figure out if that is a solution or not. So to do that, we're going to check just like we would a line. We're going to put that 2, 1 in. So remember, our 2 is our x value, and our y value is 1, and see if it works. Now the trick is you got to make sure to see if it works for both of them. So you have 2 times 2 plus 5 times 1 equals 9. So when we do that, 2 times 2 gives us 4 plus 5 equals 9. So 9 equals 9. That is true. So that's our first piece. Second one, 1 equals -2 times 2 plus 4. So we're going to go through and figure that one out. So 1 equals -2 times 2 plus 4. So 1 equals -4 plus 4. 1 equals 0. So I didn't mean to do this. Those two steps are the same. Sorry about that. But you can see that this is not a solution because 1 does not equal 0. So this part is not true. So if either one of those is not true, then it cannot be a solution. So this is not a consistent-dependent system. All right, what you do is try a second one, pause your video, and then we'll write everything up here so you can see it. So pause your video and we'll go through it. All right, so you should have had a chance to do that. So I got my work done here. So I plugged in 3 for y and 2 for x. So this was our y value, that was our x value. So I got 3 equals 2 times negative 2 plus 7. 3 equals negative 4 plus 7. And my final answer got 3 equals 3. That is true. And on the right-hand side, I plugged negative 2 in for x, 3 in for y, and got 5 times negative 2 plus 4 times 3 equals 2. So negative 10 plus 12 equals 2, and that, of course, is 2 equals 2. So this is a solution. So that is a solution. All right. That's the end of the video today. Have a good day, and we'll talk to you later.